Welcome to Module 6, Light, Color, and Image. In this module, we will explore the science of light, how colors are perceived, and the principle behind images. These concepts are fundamental for fields ranging from physics to digital media. So, what is light? Light is an electromagnetic radiation visible to human eye, commonly known as visible light. We call it visible light. It consists of wavelength that we perceive as different colors, such as red, blue, and green. So now, in the color theory, visible light is subdivided in 7 major colors, which is red, orange, yellow, green, blue, indigo, and violet. And the distribution of electromagnetic wavelengths allows us to see a specific color. So, one color, one wavelength. The uniform distribution of these wavelengths allows us to see the white color. So, the white color is basically a uniform distribution of all the other colors together. As you can see in the picture, so the 7 colors belong to the continuous spectrum of the visible colors. So now a question, how can we see color in objects? So objects appear colored because they basically absorb certain wavelengths and they reflect others. So for instance, we can see a shirt as red because the same shirt absorbs all the wavelengths except the red, which is instead reflected. White objects reflect all the colors, and while black objects absorb them all. On the other side, transparent objects don't absorb light, but they basically can bend it, creating a unique visual effect. In the color theory, there are some methods to represent the continuous spectrum of visible colors. They are the paradigms that we have set up. We have additive, subtractive, and perceptive space. In additive color models, like RGB, which is the most popular, colors are created by adding light beams of red, green, and blue. Full intensity results in white, while no intensity produces black. Equal intensities create shades of gray, and varying intensity result in different hues and saturation levels. We can set up with a graphical representation of the color space, and in this figure you can see the graphical representation of the RGB color space. So let's move to another paradigm, the subtractive color space. The subtractive color model, like CMY, cyan, magenta, and yellow, create colors by absorbing parts of the white light spectrum, so which is similar to our perception. A color model is subtractive in the sense that mixtures of dyes subtract specific wavelength from the spectral power distribution of the illuminating light. So mixing these pigments in equal quantities results in black. This model is often used in printing and material design. The third paradigm is the perceptual color space, such as Manchel system or HSB, hue, saturation, and brightness, that describe colors in terms of their basic property. Hue defines the color, saturation its intensity, and brightness its lightness. So combining these properties creates the full spectrum of colors we perceive. This space is very close to our way of perceiving colors. So now let's move to images and how the images are perceived by our vision system. So lenses reflect light to form images. The image formed by a lens is due to the refraction of light rays as they pass through the lenses. There are basically 2 types of lenses, convex one and the concave one. So let's go more in deep into these concepts. So through the refraction process, lenses create an image that can be enlarged, reduced, upright, or inverted, depending on the object distance from the lenses. Each lens has 2 focal points, equidistant from its side. When an object is beyond the focal point, so the image is inverted. As the object moves closer, the size and the orientation of the image change, as we can see in the picture. These effects are crucial for understanding magnification and projection systems. So, our visual system captures also perspective, allowing us to perceive depth and spatial relationship. We can say that we can see in 3D. Sizes appear smaller with distances, and we can experience it in our daily life, which is a concept used extensively in art and imaging technology to create a sense of three-dimensionality. So let's move to the conclusion of this module. So in this module, we have covered the fundamentals of light, color, perception, and lenses. These principles underpin technologies like imaging, photography, and digital displays, influencing both science and art. And we will see more in depth this concept in next modules. So thank you for your attention.